Okay. So the next topic is the construction and working of synchronous generator using design thinking concept. So in previous class we have discussed about the induction motor. Okay, so what about the operation of induction motor? General topic.
Rotating magnetic field, rotor operation, torque production, speed control.
Three-phase induction motor. So already we have discussed it. So it is based on the concept of rotating magnetic field, and it consists of stator and rotor. And the rotor it consists of two types. One is squirrel cage, another one is slip ring. So now we are going to discuss about the synchronous generator. So may I know what is generator? The generator.
The device is used to generate the mechanical energy to convert into electrical.
The generator which is used to convert the given mechanical energy into electrical energy, that is called generator. And what is synchronous? What it means? Synchronous generator. What it means? Generator. What it means? Synchronous.
So the generator which runs at 1500 RPM.
So the generator it runs at 1500 RPM. That is called synchronous speed. So synchronous generator means the generator it runs only at 1500 RPM. That is called synchronous generator. So normally the generator which are used in mainly power systems like thermal power plant, nuclear power plant, and many of the power stations. Okay. So how we have to calculate the synchronous speed means the synchronous speed calculation 120 F by P. 120 is constant, F is nothing but frequency, and P is nothing but number of poles in the generator. Okay. So the key components are stator, rotor, prime mover, and excitation system. Okay. So already we have discussed in the DC generator also. So may you know what is stator?
Stator, which is used to induce voltage, which is an armature.
Okay. And what about rotor? The rotor of synchronous generator. What is the use of rotor?
Generating electromagnetic energy by DC supply.
Rotor which is used to produce the magnetic flux. The rotor which is used to produce the magnetic flux. Okay, that is called rotor. And what is the use of prime mover in the synchronous generator? What is the use of prime mover in the synchronous generator?
So it is used to rotating motor.
Prime mover?
Used to it is rotating rotor.
Okay. Prime mover which is used to rotate the rotor. Okay. So the prime mover it may be either petrol engine, diesel engine, gas turbine, steam turbine, or it may be an hydraulic turbine, whatever it may be. So which is coupled with the rotor. So if the prime mover gets rotating, the rotor also gets rotated. So already with the help of rotor we are producing the flux. Okay. So now the rotor gets rotating. So when we are producing the flux by the rotor and the rotor gets rotating, now we start producing the rotating magnetic field. That the rotating magnetic field it will interact with the stator. So according to the change in flux, according to the Faraday's law, the voltage will be induced in the stator winding. So already in stator winding it consists of three winding will be there for R phase, Y phase, and B phase. So we are getting the three phase output from the stator winding. That supply will be taken out and it will be connected with the load. Okay. And next one, excitation system. So excitation system is nothing but if you want to produce the flux by the help of a rotor, so we have to give the DC current to the rotor. Okay, we have to provide the DC current to the rotor so that only the rotor gets exciting and start act and it act as an electromagnet that it start producing the flux. Okay, so for that we have to give the DC power supply. So that is called excitation system. Okay. So while doing the empathy, we are having these several questions. Number one. It is too difficult to visualize the rotating magnetic field which is produced by the rotor and how the flux which is interact with the stator. So we are unable to visualize the magnetic flux. So that is one of the empathy. And so with the help of phasor diagram, how we have to determine the voltage, on what is the direction of current, on what about with respect to the different load condition like resistive load, inductive load, and capacitive load, whether the current is lagging, leading. So like that we are unable to visualize and unable to predict. So how the phasor diagram it will use to determine the different value of lag, lead, and unity compensation. And also, according to the construction, there are two types of rotor. So one is nothing but salient pole, another one is non-salient. The non-salient is also called as cylindrical type rotor. Okay. So here in the defense stage, so there are two types of rotor will be there. One is called the salient pole rotor, another one is non-salient pole rotor, or it will be called as cylindrical pole. Okay now. So what is the difference between the salient and non-salient?
Pole வந்து air gap uniform இருக்காது, cylindrical pole வந்து uniform இருக்காது.
Okay. So as a statement, in the salient pole machine, the air gap is not uniform because here air gap is very minimum and here air gap is maximum. So here minimum, here maximum. So here you are getting the ununiform. Okay, this is the air gap is not uniform. But if you go for this cylindrical pole, the air gap is always uniform. Okay now. So what is the drawback of non-uniformity and uniformity?
Air gap is not uniform, so we can't use for high speed application. It has a uniform air speed, so we can use for high speed application.
Right? So here the air gap is not uniform. So if you are trying to rotate at high speed, so there will be a huge noise will be created, and the rotor is also it may get damaged. So it can't use for high speed application, and this can be used for high speed applications. Okay. So this is the ideal stage. The steps process involved. So in the construction of synchronous generator, so there are two types, majorly two types. There is two parts. One is called the stator. Okay, the stator is called armature. It has three windings will be there. The three phases will be distributed uniformly, 120 phase shift. And the rotor will be there. The rotor is either salient pole or non-salient pole, and we are providing the cooling system for cooling purpose. So this is the construction of stator, rotor, and cooling system. And the working principle. So with the help of prime mover, we are rotating the rotor. With the help of prime mover, we are rotating the rotor. At the same time, we are giving the DC supply to the rotor, that is called excitation. So the rotor starts producing the flux. So the rotor is rotating as well as starts producing the flux. So we are getting the rotating magnetic field. So the rotating magnetic field will interact with the stator conductor, and the flux will be conducted with the help of stator winding. So when the flux is cutting, according to the Faraday's law, the voltage will be induced in the stator winding. That induced voltage that will be again taken into the load, and it will be connected with load. Okay. So how much amount of voltage will be induced in the synchronous generator? It will be calculated by using this equation. Okay. So the next voltage regulation. So now the synchronous generator is inducing a voltage of 400 volt or 415 volt at no load condition. If the load is increased, the voltage should not decrease immediately or fall. Okay. So we have to maintain almost constant value or almost which is equal to the no load voltage. Okay. So the difference of voltage between the no load and full load, it should be minimum, so that only we can able to maintain the voltage regulation. And in order to determine the characteristics of synchronous generator, so whether we can use either open circuit characteristics, short circuit characteristics, or zero power factor correction method, or slip test. So the following can be applied in the synchronous generator to determine the performance of synchronous generator. And the next, if I want to connect two or more than two generator in parallel, okay, so what are the conditions as to satisfy to operate parallelly?
Operate the same voltage, same frequency, same parallel, same.
Generator in parallel. So the voltage which is produced by the generator, the voltage should be equal, frequency should be same, and phase angle and the direction of current, that is called phase sequence, everything should be same. So that only we can able to connect all the generator in a parallel operation. Okay. So this is the visualized working principle. So number one, we are giving the DC supply to the field, and with the help of prime mover, the rotor gets rotating, and it starts producing the rotating magnetic field. It will interact with the stator. So according to the Faraday's law, the voltage will be induced in the stator. Then that means the current which is produced in the stator, or the voltage which is induced in the stator, that will be taken into the load. Okay. So this is the visualized working principle. So this is a real-time application of the synchronous generator. Okay. So one is it can be used in the thermal power plant, nuclear power plant, hydroelectric power plant, wind energy conversion system, or small hydroelectric power plant, or some of the capacity power plant. So mainly where we want to produce electricity, so there we are using the synchronous generator, because it is independent of load. It is not depending on the load. But some of the generator, the load vary, the speed of the generator is get changed. If speed change, the frequency will change. Okay, so we are unable to synchronize. We are unable to parallelize all the generator. Okay. So this is a mind map. So according to the construction, stator and stator winding, and rotor, that is cylindrical and non-cylindrical, and DC excitation system and cooling. So these are according to the construction, and according to the operation, the EMF will be generated in the armature, and armature reaction will be presented in the system, and various characteristics can be achieved by using the open circuit, short circuit, and voltage regulation can be calculated. Okay. And according to the application, it can be mainly used in the power system, industrial power plant, the renewable energy system, and to store the energy backup. So this is a curiosity challenge. So the first question: why does a synchronous generator require separate DC excitation? Okay. So may know why it is required?
In order to produce magnetic flux, the DC generator is.
So here, for the purpose of giving the DC excitation to produce the magnetic flux in the rotor. Okay. So, and this is an assessment question. So here, what is the use of open circuit characteristics means to draw the performance characteristics of synchronous generator. And these are the few textbook and reference books. So, any doubts?